Okay, hi guys, welcome to this session, Specia Tech Talks. On this session, we'll be having a session on deploying and managing applications on Kubernetes. And our speaker for tonight, this is Ian. Ian will get a chance to introduce himself, maybe tell us what he does, where you can get him, maybe on his socials, and how it can help you with maybe if you have a problem with Kubernetes. And I hope this session will be interactive enough so that if anyone has a question, you might just raise your hand, or you can just text on the chat. I'll be looking out for your questions. For that, I'll let Ian introduce himself, then tell us more about himself and the subject for tonight. Ian, you're free to take up the stage. Yeah, you can mark mic.
Hello guys. I hope mnaweza nisikia vizuri. So I'm just trying to upload a blog about what we're gonna be doing today. Just a minute, I just upload the blog I send it to the Twitter space. So guys, my name is Ian. I don't know if you guys can see the screen. Can just someone tell me?
Yeah, I can see. I can see the poster. Yeah.
That's nice. So my name is Ian. I'm a technical writer, and currently I work at ISTL Africa, where I'm a DevOps engineer. So daily I deal with clusters and Kubernetes. I deploy applications. I do a lot of things with Kubernetes and application at the production level, which it's quite good. Today I'm gonna take you through deploying and managing an application with Kubernetes. We will be able to start from a very neutral way, and I don't know if I can post a question.
You're allowed to post a question.
Where are the messages? So how many people have interacted with Kubernetes before? Please just...
or should I help you create a poll?
Yeah, please, can you? And then also I've uploaded the blog on Twitter, and I've tagged along Specia Tech. I don't know if everyone can see it. I don't know if anyone can see it.
Okay, let me open my Twitter then so that I can start the poll first. Your question was how many have interacted with Kubernetes?
Kubernetes, yeah. For those who are joining, welcome.
The poll is up, so you can get respond. People can start responding.
Thank you. So we can start. So for today, I'll introduce the topic, introduction to Kubernetes. We'll also look at the architecture of Kubernetes. We'll look at the main components, and we'll do some fun stuff at the end. That is a demo. I'll show you some demo and how we can deploy an application. Also, I'll be showing you guys something to do with different tools that I've been using to manage my clusters, and how they are easy to use around, how you can navigate with them around. So the official definition of Kubernetes is it is an open source container orchestration framework, which was developed by Google back in the year 2014, but now it is maintained by Cloud Native. Cloud Native is a community-based organization that hosts different projects. Apart from Kubernetes, they have very many projects like Prometheus and AgroCD. They have a very large catalog of projects, and you should check them out because they are the main providers of Kubernetes. So on the foundational basis, Kubernetes manages containers, whether it is a Docker container, whether it's any technology of containerization that you have, Kubernetes will help you to manage the containers. What this means is that Kubernetes can help you package the application, can help you manage the application on bare metal, whether your application you want it to run on cloud or on a hybrid cloud, or even the edge devices. Now that you're moving to, you're getting to the edge devices and moving towards the consumers more. I hope everyone is with me. If you have a question or anything, you can just put it on the chat. I'll see it and then I'll react on it.
I'll also assist you with the questions though.
It's okay. So what problems does Kubernetes solve? So the emergence of container technologies in the current tech world, it has bring so many advantages. In that previously we had these issues of, yeah, it works on my laptop, but now when you go to production, we have some issues, dependencies don't work, such issues. But then this emergence of containerization, you are able to package the application as a single binary, and then you can deploy it anywhere. So we can be able to deploy your application anywhere and it will be able to work everywhere. So containers enable you to package the application. However, the rise of containerization brings an issue. Now, people are having this monolithic architecture and we're moving to the microservices. Although there's a challenge on that, and we're going back to the monolithic. Although back on the monolithic, we can be able to package the application in just two simple ways, and deploy it instead of having so many containers. Although concerning that, we are having many containers at the moment running. Now your application may be having 5, 6, 10 containers running, and now you get some challenges like managing the container, the security. You'll have challenges with the security, the networking issues, and this brings a lot of issues in managing it. Now, what are the features of a container of an orchestration tool? Mainly, an orchestration tool, it ensures that our application is highly available. This means that there will be no downtime in our application. Now, I'll be taking an example of an online application that is Jumia. Jumia is a very good example of it. For example, during the November Black Friday days, we are having lots of people coming in. People want to buy stuff. People want to do things. and our application is receiving a lot of requests at a given time. Now, we don't want our application to go down. It should always be up and running. Now, that is a feature of Kubernetes that helps the consumers to always have the application and the end users to always be able to view the application at any given time. So there's a question about if I can send the slides. I have uploaded a blog about what I'm going to be talking about. So everything is on the blog. Also, I can share the slides anytime, and I'll be doing that after the talk. Thank you. So another feature of a orchestration tool is it helps us scale our application. Now, back to the Jumia application. During that November Black Friday, maybe our application was just receiving normal requests. Now, during this time, it has a large amount of requests. So our application should be able to adapt to that and increase and scale in size so that people can come in and users can be able to buy anything and do anything from it. Also, an orchestration tool can assist in disaster recovery. For example, now, if something happens in our application, we will be able to roll back to what happened. If there's a disaster happening or anything happened, we can be able to go back to application and pull it up and get it running. So that's the main features of orchestration tool. There are many orchestration tools out there, by the way. Apart from Kubernetes, there's Mesos, I think, and there's the one for Docker. I've forgotten the name just a little bit, but yeah. But now Kubernetes, over the last years, it has been the leader of orchestration tool, and every company and every organization in the world is leveraging on the fact that they will be using Kubernetes to bring out its benefits and help the organization prosper. Now, what is the Kubernetes architecture? So from the diagram here, a Kubernetes cluster consists of at least one master node, which is connected to several worker nodes. Each worker node runs as a process called kubelet. Now you can see very well that there's a kubelet running in the worker node there, and there's another kubelet, it's cut off, but there's another kubelet working on the other worker node. Now, kubelet is the component or in the Kubernetes ecosystem which facilitates communication within the clusters and executes tasks on nodes, such as running the application, debugging the application, or any other function you want to run in it. So each worker node has containers of different applications deployed on it. So depending on how our workload is distributed, you will have different number of containers running on each worker node. The worker node is actually where our application is going to be running, and we will be able to control our application, the worker node using the control plane. Now here is the control plane. We have here the master node. Now the master node is responsible for managing and controlling the cluster. It comprises several processes that work together to maintain the cluster's overall health. For example, now the first thing you can see here is the API server. Now, the API server is it's more of a container also that serves as the primary entry point into the cluster. So it acts as a user interface. We're using the Kubernetes dashboard or the user interface, API, or CLI command tools like kubectl. You can be able to interact now with your cluster very easily. We have the control manager that monitors the states of the cluster, ensuring that any issues are addressed promptly. For example, it can detect when a container has failed and initiate a process to create a new container. Now, when the process is initiated, it goes to the scheduler. Now, the scheduler is it intelligently assigns containers to worker nodes based on their workloads. It considers factors such as resource requirements and current utilization to determine the most suitable worker node for deploying the new container. And last but not least, we have the etcd. This is the data store, maintains the current state of the cluster at any given time. It serves as a central source of truth for the cluster configuration and status. Back in the previous slide, we saw that orchestration tool can be able to do the backups and disaster recovery. Now, the main thing that does the disaster recovery actually is the etcd key value store. Another component of the control plane that facilitates everything is the virtual network. Now, the virtual network plays the crucial role for facilitating the communication between the Kubernetes cluster by interconnecting all the nodes. It creates a powerful unified machine that enables it to seamlessly interact between the containers and everything that is running. I hope you are at par with everyone. Thank you for the thumbs up. So what are the main components of Kubernetes? So here, I'm going to talk about the main components that you will be able to interact with when you are dealing with Kubernetes, from pods, services, deployments, secrets, and config maps. And before I go on, if you don't know what's containerization or Docker, there is a video on YouTube done by Spacia Tech and Moses. It explains really very well about containerization and everything to do with that. So kindly check on it if you're not familiar with containerization. But if you're familiar with it, let's go on. So what's a pod? So the pod is the smallest unit of Kubernetes deployment and serves as an abstraction layer over a container. It encapsulates one or more closely related containers within a single unit. If you have experience with Docker containers or images, you can think of a pod as a runtime environment or an additional layer built on top of a container. This design choice enables Kubernetes to abstract away from the underlying container technology. For example, if you're using the Docker or Containerd or anything, now Kubernetes abstract that layer, allowing for flexibility and possibility of using alternative containers. Typically, pods are designed to run only a single container within a pod. But in other circumstances, you can find that one pod contains more than one container. It can be the helper container, the init container, or a side container which runs next to it for logs and everything to assist the main container in running. And then you might be asking yourself, how does the container, let me just go back to this slide. So you might be asking yourself, how does the container, the first container now, my app, connect to the database, which is running on the same, it's two different containers, two different pods running on the same node. Each pod receives its own unique IP address and not the container. Now we have abstracted away from the container. Now each pod gets its own IP address. This internal IP address facilitates communication between pods, allowing components like application containers to interact with the database containers seamlessly. Remember, pods, they can die anytime. They can be terminated anytime. For instance, if a database container crashes due to an issue with the application inside it, a new container will be IP address, which can be inconvenient if other components are using the previous IP address to communicate with the database. Now, when a new database has come up, it has its own IP address, and that's a little bit of an issue. But then Kubernetes has a way to solve it, and that is by the use of something known as the services. Now, services, a service in Kubernetes essentially provides a stable or permanent IP address that can be associated with each pod. In our example, the web application pod, there's my app, and the database pod will each have their own dedicated service. The key advantage here is that the lifecycle of a service and a pod are not connected. So when our pod dies, we have a static IP address and a permanent IP address. When a new pod comes in, it will just fit in the new IP address. With the new IP address, and then the service is running next to it. Now we are having a seamless way to connect to the new pod. To enable access to our application via browser or anything, because at the end of the day, we have to access the application. We have to have an external service in Kubernetes, and which exposes our application to the browser. External services allow communication with external sources. However, it's important to keep your database secure and not expose it to the public request. To achieve this, Kubernetes also has internal services and external services. And you can specify this when you're creating the application. When you're creating the pod, you can specify, now, I want my service not to be exposed outside. Now, I'm creating an internal IP internal service for it. If I want it to be accessed outside, I'll create an external service for it. So we just seen some few concepts, the services and pods. Next, we're going to be looking at what is a config map. Config maps and secret. So pods use services to communicate with each other. Traditionally, configuring the database URL will require you updating application, properties, file, and you build the image again. If the service endpoints change, the process can be time-consuming, going through the building again. Now, just our service has changed. Our service endpoint maybe has changed. We have to redo it. But then Kubernetes has a way of making it seamlessly, and we shouldn't go through that process of rebuilding our application, deploying it, and doing everything. So Kubernetes addresses these issues with config maps, which allows you to store external configuration, such as the database URL, separate from the application. Config maps are connected to pods. So when you need to update the service endpoint, you can simply adjust the config map without rebuilding the application or going through a complex deployment cycle. While config maps are good in storing general data, they may not be suitable for storing sensitive data. Let's say you have in your password, the database password or database username. It's not good to store it in a config map. And that's where the secrets come in. So secrets, they're just similar to config maps, but they are specifically designed for storing sensitive data, such as credentials. Although secrets store the data in a base 64 encoding form, this does not provide encryption to it. So it's always a good practice when you are in production to use third-party tools to encrypt your. You can use third-party tools to encrypt the secrets so that no one can be able to access it. I hope you are at bar with everyone. If you're at bar, please just send a thumbs up. Thank you, thank you. So next, I'm gonna be looking at the deployments. But before I look at deployments, there's one thing I forgot to put it up. That was volumes. The volumes in Kubernetes. Volumes work by, okay, now Kubernetes, the main applications that run in Kubernetes are stateless application, the applications that do not store data. But now, when you have an application that stores data, let's say a database or anything, you'll need to configure it with a volume. Now, configuring it with a volume, you can have the persistent volume on it. You can use different tools to do that. For example, you can use the Longhorn for long storage of your databases or anything. So next, I'm going to talk about deployment. So in order to minimize downtime and take advantage of this distributed system that we are having at the moment and containerization, we can replicate our application across multiple servers instead of relying on a single pod. We can create replicas running on different nodes, all connected to the same service. Since the service has a static IP address, like we talked a few seconds ago, and acts as like a load balancer, it can distribute incoming requests to the least busy pod. Rather than manually creating multiple pods, we can define a blueprint of the application pod and specify the number of replicas we want to run. So this blueprint is called deployment. In practical, instead of creating pods, we'll be creating deployments because it's easy to manage deployments than managing the pods. So you remember we talked about pods are an abstraction over containers. Now deployments is an abstraction above the pods. So you can be able to control the deployments. Now inside the deployment, we have the pods. Now inside the pod, we have the container. So if one pod fails, the service will be forwarded to a request to another available pod, ensuring that the application remains accessible to the users. From the diagram there, you can see that we have a deployment, and then there's a replica set. And then you have our first pod, second pod, and our third pod. Now, the deployment controls the above, the odds below it. And we can scale the deployment, scale up, or scale down, very, very easy than scaling the pods. Now, deployments are good for stateless applications, and we might be having an issue when we have our application, maybe our database running, and because, for example, you might be wondering that since the database may be having the data itself, replicating it in a deployment is not feasible. When creating replicas of a database, they all need to access the same shared data storage. To avoid inconsistency, a mechanism is required to manage which pods are writing to the storage and which ones are reading from it. So this component of having the database is called a stateful set. So with stateful set, you can deploy your database, let's say MySQL, the MongoDB, or any other stateful service instead of using deployment. So just like deployment, stateful sets handle replicating the pods and scaling them. And remember one thing, stateful sets are mainly used for databases, but although it may be hard to configure a stateful set in a database, but you can give it a try. It's always the best way to deploy our databases. So with two replicas of application and database running, we have seen how we can utilize some components of it and how we can deploy it and everything. Now we're going to be talking about the Kubernetes configuration. So all configuration within the Kubernetes cluster are managed through the master node, like I previously talked about it, via a process known as the API server. So various Kubernetes clients, such as the UI, the kubectl, communicate with the API server to send configuration, communicate with the API servers to send configuration to read, and then the API server transmit down the communicated values. So this request, Kubernetes configuration, most of it is written in the form of YAML or JSON, which they can accept all file formats. And remember one thing, configuration in Kubernetes are declarative, which means you specify your desired outcome in a YAML file, and then you deploy it or you apply it. And Kubernetes works every now and then to achieve the state of the application. For example, if you declare that you want 2 replicas of a pod and one of them fails, the control manager detects that one pod is not functioning properly and then takes the appropriate action to restore the desired state, ensuring that that what you have declared in the configuration is maintained and the system and the Kubernetes, you have the actual output of it. So every Kubernetes configuration, they have these 3 main parts. I hope we can be able to see it. First of all, we have the metadata. This is where we have the name, what's the name of our application, or what's running, or what's there. Next, we have the specification. We have under the specification, you specify how you want your application to be. Let's say you have 1 replica, 2 or 3, and so on. So specification really details about how we want our application to be running or what's inside the application. Also under the specification, we have the containers and the container port number that we need for application to be running in it. And the last configuration file that we have is the status. Now, note that you shouldn't be writing the status. It's not always displayed on the YAML, but it is a component inside the Kubernetes where it always checks the status of the YAML. And I've talked about if the status does not match what is desired, then the scheduler will talk to the control plane will talk to the controller manager will talk to the scheduler, and the state will be restored. This is our YAML configuration for that. One thing about YAML configuration that you should know before you start interacting with Kubernetes. First is that YAML, they're very, very friendly, not that so hard like other languages like Python or anything. They're just easy to use. But one of the things to do with it is that it has a very strict indentation. For example, if your file has incorrect indentation, it will be considered invalid. However, once you become familiar with the syntax, it is simple to use.
Hi, Ian, we're having a question on the chat from Njogu. Okay, he's asking, in the containers part, if he's to use MySQL DB, will that also change? Okay, I didn't get what he actually meant by will that also change, but if you get,
I think what he's asking is oh, let me just go on the previous slide. For example, if you're having the MySQL database, the name of the container will change. Of course, it will be MySQL. You can easily go to Docker Hub and get the image name for my MySQL database and easily deploy it. I hope I have answered your question.
Yeah, it's answered. Yeah.
So with YAML, you can store the configuration file alongside your application code. Since the deployment and service configuration are also in form of a code, and we are having in the industry, we are having this thing about infrastructure as code. So when you write your YAML configuration, let's say in a VS Code or in any code editor that you like, you can be able to store the configuration code in a Git repo, and Kubernetes you can also refer to Kubernetes, and it can be used to deploy our application. So next, I'm going to be talking about how to set up a local setup in your laptop, which is pretty easy. So in Kubernetes, in production level, most production level, you have to have at least 3 or 4. It's recommended to have 3, but I think it should be 4 control planes, because our application should always be running. It's never good to have one control plane, because if it dies, now our whole cluster is gone. But if you have like 4, our cluster will stay up. But now that's a challenge if you want to test something, because in your laptop, it's a little bit hard to have such a very huge setup. And Minikube really solves this, because Minikube has one node. It's a single node cluster for testing and deployment and development. Minikube creates a single node where both the master and the worker processes run on the same node. This node has a Docker runtime installed, allowing you to easily test and learn the concepts of Kubernetes in your local environment. So, for example, if you're using a MacBook, or if you're using a MacBook, you can just run the brew install Minikube. If you're using Windows, just go to the official documentation of Minikube, and then you'll be able to download Minikube. Now, for today, I have Minikube running in my laptop that I'll be using to showcase what we're gonna be learning today. So remember, Minikube also needs drivers to run on it. You have to install some Docker also in your laptop, so that Minikube can create these containers, which are nodes that you can be able to now run your application in it. Or you can also have a virtual machine or something of that sort to help out to run Minikube. But just check it out on their documentation. It will get easy to start with it. Another component is the kubectl. I hope we are together. Anyone with a question? Good. There's no one with a question. I hope
no, there's no question. Yeah.
Yeah, I hope I'm clarifying things as we go on. So kubectl is a command line interface tool that allows you to perform a very wide range of actions. You can use it for creating and managing resources like pods, services, and deployments, to scaling the application and anything. The main thing to do with kubectl, it's one of the CLI tools that are very, very efficient to use when you're managing a cluster. It's very, very easy to use. You can just get started with it. There are many tools out there. There are many commands out there you can go through and see how it works. Another thing I'm going to be talking about is, another tool I'll be talking about is Lens. I don't know if anyone has used Lens here, if you have interacted with Kubernetes. So I'm going to try and show you. Just a moment.
As Ian is launching that, there's a poll that is still running. I haven't ended it. So the poll was just asking how many people have actually interacted with Kubernetes. So you can just give your answer on the poll. We'll just be checking. So we have a question here by Dennis. Yes, Dennis, you can ask your question.
Okay, you can hear me?
Yeah.
Okay, I just have a question on the etcd database. Is it for the production? Is it you can set a etcd database on a separate server, or just on the having the etcd on the master?
That depends on your setup and how you want to achieve it. But depending on the application, I think one of the best ways in production is having it in a separate server, because this is where, if anything happens to a cluster, we're gonna refer to etcd, and yeah, we're gonna. I think Moses has also answered that. But it's good in production to have it in a different server or on the same server. But if it's good to have it on a different server. I'm still trying to get this screen up. Anyone with a question?
I don't know whether Amos is asking a question or he's just commenting. Amos is saying, "Yeah, oh yeah, he's making fun of having a backup on the same server."
I don't know why I can't be able to see the other screen, but okay, let me just continue with where I was. So I was talking about Lens. Lens, it's a very good tool. For example, we are accustomed to use VS Code, which it's so good, but now VS Code manages it's used for very many purposes. But Lens, it's specifically used for Kubernetes, and with Lens, you can be able to now. It has a very good UI. You can be able to interact with your cluster very easy. You can be able to deploy application with your cluster with Lens. It's one of the best tools I've used so far. Another tool that it's good. It's we're in this situation where we're having AI everywhere, and in Kubernetes we also have an AI technology coming up. So this is a So there is a tool known as K8SGPT. Kindly check on it. It's a very, very intelligent tool. It's an open source tool. I think it's been on the market for 1.5 months or 2 months. Do not run it on production, kindly. It's not well tested, but it's a good tool whereby it will scan your cluster, it will tell you the problems, and it will also give you a solution to how you can solve the problems that you have. Next, we're gonna be doing the fun stuff now. We'll be doing the demo. I'll try to demonstrate how we can be able to deploy application. Now, this is what we will be doing. I have there's a web app that I tried to get one, which is very easy to understand. So this is a web app. We'll deploy the web app, and it will be communicating with the database using the service. We'll also deploy the secret which contains the password and the username. We'll also deploy the config map, whereby the web app will be able to now communicate with the MongoDB. Also, we will be seeing our application live from the external IP. So let me try and API together. So the tool is k@sdpt. I don't know what's Commodore, but I'd love to know it. I don't know if you can be able to see my terminal. Can you see the can you can you see the lens interface? So this is the lens. You can see it. So this is the lens interface, the UI. You can
it's loading. It's not yet loaded on mine. Maybe someone is still.
Are you able to see it now? Hello, anyone able to see the lens interface?
Okay, now not yet. Is it possible like to increase it more? Okay, like you can see, but like the wordings on the terminal they're a bit far.
No, I'm not talking about the terminal. I'm not talking about the terminal at the moment.
Okay, it's fine. It's fine then. You can see.
Can you see the? You can see the interface running here.
Yeah, you can see it.
So this is lens. I was trying to bring up lens first. You can see it has a very good UI. You can see the number of pods running, the deployments, the replica sets. You can go down to anything that you want to see in your cluster. This is at least better than the official Kubernetes dashboard. We can also see the config maps, the secrets, anything that you want to be able to see in your cluster. And then Lens also connects with different types of clusters. You can connect it with your EKS, your on-prem, in the cloud. Anyway, feel free to go around with it. I'll now try to use the So are we able to see the VS Code?
Yeah, it's visible. We can be able to see it.
Thank you. So previously I was talking about the different types of configuration. So I was not sure if our application, if it's gonna be running. So I already came up with the YAML file for it. So here we have this is let's start with the Mongo YAML. So this is it's a deployment. We have here the name deployment. We have here the metadata. And the metadata has the name, the Mongo deployment, and the different types of labels. Labels are used to group different components in your clusters. We can also see here the specification. We have one replica. You can be able to change the number of replicas you always want in your application. There's a template here. Now, previously I was talking about deployment being an abstraction above the pod. Now, the pod comes in here. For example, we have here here is the template of a pod. So when you are scaling it, instead of creating a new pod, Kubernetes will go down to look at what's the template of the pod that you always want. Now, when you replicate the deployments, it will take the configuration of this template and then deploy another pod using this specification. So here we have the label, the Mongo label. It's always good to use labels because you have to know, Kubernetes wants to know it's talking to who, and in order to group these different components together, Kubernetes uses labels to do that. We have here the container. Now we'll be running the MongoDB container, and the image, we can find the image from the official Docker Hub, official MongoDB image. And MongoDB has a container port running at 27017. So different, let's say if you're using the MySQL, has a different port to MongoDB. So always check out on that. I'll come back to this in a minute. But now there's here the resource limits. One of the good things, one of the practices that you should be doing in production is you should always be having the resource limits available, because you don't let the pod just use any amount of resources. You should limit it on what it should use and what not to use. So now every deployment has a service, because it has to talk to something else or communicate something else with something else now. And in our setup here, we have the Mongo service, which is this is the Mongo service. It's simple. We have here the metadata, the name, the Mongo service. We'll need this name later on. We have the app. Remember the selector app. We have here Mongo, and we also have here Mongo. So Kubernetes now it automatically detects that this service is related to the deployment Mongo, because we have the selector app Mongo. So it also has the ports. You can put it on any port, but this should be the port number should be the same to what the container port is running on. But the target port can be different. But it's good to have it just running at the same place. Next, I'll be looking at the web app. It's just typically the same thing. We have here the image. We have here the container ports and the resource limits and everything. We have here the service also. It's a type service. We have the Mongo configuration YAML. Remember when we talked about the config maps? This is now the config map. It's a kind config map, and the name is Mongo config. We'll be using this Mongo config now to make sure that now our Mongo app is communicating with the web app. We also have the Mongo secret here. Remember I talked about base 64 encoded. Now this is the base 64 encoding of our password and our username. It's good to have this, but now remember in production, you shouldn't be, anyone can decode a base 64 thing. So you should use an external service an external tool or something external to store these secrets. So I have Minikube installed. So I can check the Minikube status of if it's running, if everything is fine with it. I think everything is good. Let's see what's running in our cluster. I have okay, the application is already running, but I can just take it down. So we're gonna be deploying now the full application, but before you should also know the sequence of how to deploy the application. For example, now there's a question.
Bravin.
Hi, Rotich.
Yeah, hi.
Your presentation is good, but your screen is fainted. So can you increase your font, tafadhali?
Oh. Is that better?
Yeah, it's good. Thanks.
Okay, thank you for that. So we're going to be deploying our application. First of all, since we can't start with the Mongo itself or the web app itself, because it needs something else to be running so that it can communicate with it. So in our setup here, I will start by deploying the Mongo config YAML. So remember the sequence of it. We have to deploy first the config map. Already deployed. Now we deploy the secret. And then now we already have now the config and the secret running. We can be able now to deploy the Mongo, because Mongo needs these two deployments to be there first before it starts and gets running. So let's deploy it. It's already, remember we had the deployment and the service in it. This is the deployment, and then we had the service here. So already Mongo is deployed. You can check if it's deployed. Yeah, so it's already deployed. I was talking about let me first deploy I was talking about the K8s GPT. So we can see it in action. You have to just analyze. This command K8s GPT will run through our cluster and detect any problem. For example, now I have this the host path here doesn't exist. I think I had a problem when installing the Minikube, but you can see how the K8s GPT can really help you in when you are trying to come up with an application. Let's see what's running in our cluster. So here I already have the Mongo deployment, which is in a ready state. It's 85 seconds ago. The replica set of it. We have the service, the Mongo service, which was also deployed. Now we'll deploy our web application. The web app is now deployed. Let's check on it. It's already deployed, the web app here. It's in a ready state and it's running. So now everything in our cluster now is running. But there's something I never talked about. Now we have to expose our cluster now to the outside world. I talked about external services. So in our web app here, when you go to the service, the kind service, we have to specify the type of service we want. I have exposed it as a node port. You can have a cluster IP. You can use the load balancer. It depends on how you want to run it. And remember, when you're using the load balancer here, and then you deploy the application in a cloud environment. Now the provider of the cloud environment will link their load balancer with the application load balancer that you specified here. So I have the node port there, and the node port is running on 3100. You can also get the services. Here you can see that our web app service is running on port 3000 and port 3100 TCP. We also have the Mango service. Remember, we talked about internal services. Cluster IP is an internal service. So this Mango database is not exposed to the outside environment. You don't want anyone to be able to do anything with the database. So we will be able now to view our application and just run. Now to view the application, we can use different ways. For example, you can port forward it, or you can use the IP address of the Minikube running, and then you attach it to, you put on the last side, you put the node port on it, then everything will be good. Let me just check the IP. My IP address is this. So in a web browser, I'll put the IP address, and everything is it's running well. Our application is up. You can be able to see it. I hope you guys can see it. Please just let me know if you're able to see it. Anyone?
Yeah, we can see it.
Thank you. You can interact with it. You can say, remember, it's connected to the database. And that's now our application, which is now up. And that was a small demonstration of how to come up with a cluster, how to configure it, and how to deploy it. Anyone who has a question, feel free.
I have a question.
Okay.
The IP address that you just showed us, does it give it to a public audience, or it's just you can get it from there?
No, it's just me who can get it from here, because it's running locally, so can't really get it from anywhere else.
We also have a question from Dennis Yegon.
My question is, can you display the performance of the cluster using Lens?
Okay. As I'm setting it up, anyone else with a question, feel free to pop it up.
Yes, Amos. Amos, you raised your hand. Do you have a question?
Oh yeah. So I was just asking, what is the advantages of using Kubernetes and not just the server itself?
Pardon? What's the advantages of Kubernetes?
Yeah.
Kubernetes brings it really does a lot of advantages. I mentioned a few. For example, you can be able to scale your application. I was talking about Jumia, the Jumia website. Using Kubernetes, you can be able now to scale your applications. You can also provide more security to your application. It's easy to manage the containers.
Okay, explain more securities part.
Okay. Now, there are many tools. Kubernetes works with a different set of tools together to bring up policies. Let's say, for example, you can use the open policy agent with Kubernetes. They integrate very well. The open policy goes do you know about the container, the Center of Internet Security? So they have a very long list about how our applications should be running and everything to do with it. So when you're integrating Kubernetes with let's say open policy agent, you will be able now to see how is your application running. Is it more secured? Are things running well? You're following the standards of the international standards of security of how applications should be running. Another thing to do with security, for example, in our cluster here that we have running, it's the container when it was on its own self wasn't that okay. It was secured, yes, but not as much as now it's running now in the cluster, because to be able to access now a cluster, you have to Kubernetes has this RBAC rules, a role-based access control, which regulates who is able to access the cluster, who is able to do this. This brings in another security feature in our cluster, which is also a good thing.
So that means that you're securing yourself from other developers who can access that server, not other people who can access outside people, right?
Yeah.
So that means the security side is on the server itself and the developers within, because I think the opening port part, maybe you can use UFW firewall to close any port that can be exposed. So so everything to do with ports, it is securing yourself from the developers inside that server, right?
Kubernetes, it secures itself from the inside, but also you can use other mechanisms to ensure that your cluster is secured. For example, for me, I use Rancher. I don't know if anyone here has interacted with it. Have you interacted with Rancher?
Oh no, I don't know.
Oh no, Rancher provides more security features from the outside that manages the application, no one will be able to now interact with the pods which are running here and there. There's someone who asked about if I can show the cluster states with Lens, right? So this is how Lens is. For example, we already deployed 2 pods. We have here the Mango deployment and the web deployment here, the default namespace. This shows that our containers are in a green state, meaning that they are able to run. You can see the deployments. We had 2 deployments. We didn't have a daemon set. Neither did we have a stateful set. We have here replica set. You can see the different aspect of the Lens. For example, we did deploy a config map. So we have here this is the one we deployed, but Kubernetes comes with its own config map when you set up the cluster. We deployed a secret. There's a secret here. The secret is here. Also, you can be able to change anything. Now, for example, the password was the Mango password. With Lens, you can be able to see the password and change it. You can also see the username, and then you can be able to change it and save it. You can configure the resource quotas. And remember, there's a plus button here. You can create a new resource quota or anything you want to create. Let's say you want to create a secret. You can just click there, give the secret name, where you want it to be running, the state of the secret. You can see how it's quite easy to create something from there. Also, you can create something here. Now, let's say we want to create a deployment, an Nginx deployment. You can just see it provides you with a template, an already made template for you. You can just edit the template and just create the application. So it's creating. And the application is deployed. Now the Nginx app is deployed. You can go and check the deployments. There, it's processing. We have 3 pods. It's running on the default namespace. So using this the Lens, it's easy. You can create the roles here, cluster roles, role bindings. You can also deploy Helm charts with it. You can click on the charts here and be able to deploy a Helm chart. You can search for charts here and releases. It's quite an interesting tool. You can see the namespaces in our clusters. We have the default here and some namespaces that I had them running. You can see everything that really you can be able to do with Visual Studio. You can do it in a better way using Lens, because Lens is specifically for managing Kubernetes. But you can also use in Kubernetes. You can also see that it has this extension for Kubernetes, and under the Minikube here, you can see that you can also see our namespaces. But comparing this to Lens has a way that it's easy to see things. Now, instead of just having something on the side here running, we can with Lens you can see things in a very clear manner. I hope I answered that question. Anyone else with a question, please feel free.
And according to whatever you have said,
Yes.
You've said that the Kubernetes has extensions on VS Code. So do we also have a Lens extension on VS Code that is usable on your, according to your experience? And if there is an extension, how is it according to you? Can you compare it with the one provided by Kubernetes, or is it worse than whatever you have on your end?
I don't know. I'm not sure if Kubernetes. I'm not sure if VS Code has an extension for Lens. I hope that was the question, right?
Yes, that was the question.
I'm not sure if it has an integration together, but I'll check on it. And but the way I've been using it, I think Lens offers something more than the VS Code itself, and then yeah, that's what I think. But if now let's take it this example. We are having, let's say, 5 different clusters running. Now Lens supports different types of clusters. Let's say we're having our development clusters in Google and our production in AWS. We have our testing in Azure. Yes, Lens can manage all these clusters, these 3 clusters, but not as effectively as you will want to. Now there's a tool known as Rancher. You can just check it out. It's quite a good tool. If you're working in big organizations where you're having, let's say, 10, 20, 30 clusters running, with Rancher, you can be able to manage all these clusters in a very, very easy and seamless way. Just check it out on that. Yeah, I hope I've provided something extra.
Yes, thank you.
Anyone else with a question or a suggestion or thumbs up also, just feel free. The space is open.
Rotich,
Yes.
Despite the questions that I'm asking, I don't know if I'm alone, but I think there are also some few of us here who have not interacted with Kubernetes before.
Okay.
And personally, I would like, I was suggesting if you could give us a roadmap of how you achieved to be an expert in Kubernetes, and if any, you can share the resources that you used with us so that you can also become as fluent as you are in Kubernetes.
So actually, for me, I think one of the things that I used as a resource to learn, I think books are very, very good. They're one of the best things to use when you want to learn. I'll just show you a book here. It's known as the Kubernetes in Action. It's written by Marco Luxa. Let me just a moment. Can you guys see me? So there's a book. This is one of the resources that I've been using. You can try it. It's called Kubernetes in Action. I'll just type it there. It will assist you to move from starting to security. It has very many topics about Kubernetes, from starting to the security features and policies, networking, and trust me, networking in Kubernetes is not an easy task. I have also some blog posts. You can check it out in Medium. One of the resources that is very, very recommended that I'll tell you is YouTube. I've learned a lot from YouTube, and check out on For example, she's called Nana. Check out her content. Also, the CNCF has this wide catalog of videos in YouTube where talks from different parts of the world, people come and give talks every now and then. So I will suggest that you get time, go and check on the talks, check on different YouTube videos on what is Kubernetes, how to get started with it. And one of the easiest things that I have found is you do when you test things. Just now that I've talked about Minikube, try installing Minikube into your local environment, and then just try this simple setup. You'll be able to see that you'll be able to learn from it, and that's one of the easiest way to learn. Any other question?
Let's start the book again. What was the book again?
The book is Kubernetes in Action. It's written by Marco Luxa.
Okay, thank you.
You're welcome. I think that was my presentation up to there. Anyone with anything you want to add on, feel free.
Yeah, there's this comment. There's this Dennis Yegon is saying that he's looking for a role on Kubernetes, and he says he has good experience. Dennis, I'll try get your contacts. Maybe if we come across maybe one or two opportunities here and there, and maybe if Ian can also get you some connections. I just gives out on value connections more than anything.
Yeah. Actually, where I work, they are looking for someone, but I don't know if it's very soon. But I'll keep you in touch. Just follow me on Twitter, and then just inbox me. Let me get your connection, and then anytime if something comes up, I'll just let you know. So I'll leave here my Medium. I have lots of resources on Kubernetes, including this talk that we have had today. I published it on Medium just a few minutes ago. It's in a form of a blog. Everything that I've talked about is in this blog. Using it, you can be able to start interacting with the Kubernetes. I've talked about different perspective of things and how to deploy it, and literally everything. I'm gonna be posting just a minute. I post my and I want to encourage you guys. The one who wants, anyone who wants to start with in Kubernetes, just go out with it. I think it's one of the technologies that will be changing how we deploy applications, how we run applications in production, starting from a few years ago, but now it's being adopted in Kenya in a very, very, very fast rate. I think most big companies in Kenya currently, they are running their applications still on-prem. So, or they want to move to cloud. So Kubernetes really helps them move to cloud or on-prem. And one interesting thing is there's this product of Kubernetes called K3S. It's a very, very light cluster. It can be deployed in phones, in edge devices, anywhere where you want your data to be processed very fast. Kubernetes also, I think we all know this ChatGPT and how it has revolutionized things around. One of the things that it's quite good is that ChatGPT actually uses Kubernetes to run because of the high demand which it operates on. So Kubernetes really, it's a thing that it's changing how things we deploy application and how we run things.
Okay, thank you, Ian. I don't see any more questions on the chat. Maybe just give some directions. Maybe someone who wants maybe to join the community itself. We Speciatech, we are an online community. So if you wish to join, we have a Discord channel. So just search Speciatech. Let me just check if I can share the links to the Discord server. No, okay, not on this machine.
There is a question. I don't know this person is asking about. That means if I have Golang app, I can do. Yeah, actually, yeah. If you have a Go application, it's very easy to deploy it into in your cluster and run with it. Very easy. So try it out. This is a request to Jimmy and Speciatech. I think Kubernetes is it's one of the tools that as Speciatech we should be discussing about it more oftenly because it's something that is impacting the production level in companies and everywhere running in it. So we should be having more sessions on Kubernetes and DevOps. Kindly please help us bring up this community. And also, I don't know, I talked to, I've forgotten the name, the other guy from Minnesota Kidogo.
Juma, that is Juma.
Juma, yes, I was talking to Juma, and in the world of Kubernetes and the cloud, we have, there is a community called Kubernetes and Community Days, Kubernetes Community Days, KCD. It is hosted in every other country, every other town, except Kenya. So Nairobi, we don't have such a community which is up and running. We had people who had requested for that. I saw 2 people managing the community, but the last time they were active was like, I think 2 years ago, which that's not good. During last week, I saw a request from someone working for Microsoft in Kenya, requesting to be able to, he pulled a GitHub request for Kubernetes Nairobi, KCD Nairobi. So I'm encouraging Speciatech or anyone, if Speciatech can be able to give birth to this KCD Nairobi, it will be a very good thing, and I will be appreciating it. Thank you.
And so I'll try. We have quite a number of guys on our community. Maybe we get to see maybe if the DevOps channel, if we could build this.
Yeah, actually the KCD is based on DevOps. So you can have the KCD building up the DevOps community under the name KCD. Plus, the CNCF offers, I think they offer these incentives and everything that can help you start up the community and run it well. And have the events, they can sponsor the events also. So kindly please check on it.
Sure. I'll have to check on that. I ended the poll a few minutes ago, and it is quite true that 1 out of 10 guys have interacted with Kubernetes, and that is unfortunate because we interact with decentralized applications each and every day. We work with applications that are running on Kubernetes, maybe on a daily basis on our phones, on our devices. And this is some technology as developers we should all know how to develop. I know, like as Speciatech, as the backend guys, I know of some products that we are launching on Kubernetes clusters. So I think this is something, if we learn, we get to know about how things actually work on a production level. Just a moment. I'll also take this opportunity just to mention some of the things that we are doing at Speciatech as I try to end this conversation for tonight. We don't want to take too much of your time. Okay, firstly, we have our maiden project. This is the Mentalist platform. So with Mentalist, this is a platform where people will be able to get what we call a personalized mentorship platform. I think I can get, I don't know whether Ian, you give us a minute or two about Mentalist kindly. And as Ian gets to the mic, we are an online community. I shared the Discord server links. So if you would wish to join Speciatech, the online community, maybe we have various channels. We have a job channel, we have an open source channel, we have for front end, for back end. So whichever stack you belong to, I think we have a place for you at Speciatech. Ian Mugenya, if you, yeah. Okay, it's all right. He's not in a position to talk. So the Mentalist platform is just a platform that allows for one-on-one mentorship. So like you see the mentorship we are having here, this is a group session where people join, we listen to someone presenting, but with Mentalist, we'll be giving a one-on-one. So it's you to decide on what you are talking on, what you want to be mentored on. So it's on a you basis. So if you'd wish to join the waitlist, you can just click onto mentalist.com. I'll be sharing the links. Otherwise, it's been a good session. Thank you, Ian. I personally didn't know how to go through. I've heard of Kubernetes before. I know about some of the technologies around Kubernetes, but I've never before had an interaction with. So as you are trying to do some things on your machine, I was also trying to just install and just try to play around. So I think this will be a journey for me, and I welcome. Okay, each and every person. It's 1 out of 10 guys responded that they know Kubernetes. So I think this is a starting point. If someone would want to start off on Kubernetes, this is where I think this session has been informative. So wanaanzia hapo. Okay.
Just a moment. Thank you guys for coming, and thank you for listening to me. It's been an interactive session. Thank you for Speciatech for giving me this opportunity. I'll be looking forward to being such events again. Thank you.
And it's I'll try as much as and push for more DevOps sessions. I know for people in DevOps, there are sessions in Honga Kidogo because people in DevOps, it's very hard to get to them. But at Speciatech, I think we already have a budding community of DevOps guys. So, and we also had, I think I met Ian on one of the events we had. The first event we had, the first physical event, we had on DevOps, which was some weekend ago in April, and I'm already enjoying what I'm getting from the community of DevOps guys. And thank you, Ian.
Thank you.
I think at this point, this is the point that we'll be closing the session unless we have any further questions. Maybe something you want to know about Speciatech. Maybe I'll give a moment or two to answer such questions. Otherwise, I'll allow you to leave the session. It was quite informative, and thank you guys. Okay, Yegon, you're asking for someone's Twitter account. Maybe you share it.
Okay, here is my Twitter account. Just let me post for you. Also, you can find the blog for what we have talked about today there.
I actually shared it even on chat here. I can reshare it for the blog that you did. Okay. So this video will also be posted on YouTube. So look out for it, maybe tomorrow or on Monday. This video will also be on YouTube. Thank you, guys. I think that's all we had for tonight. It was quite